So I'll start with a bit of a recap of what we'll need for this presentation, and then we'll go into how the protocol, the Ethereum protocol, can mitigate MEV and how it can be done out of protocol, which was what CM was talking about. So we'll start with maximum extractable value is the maximum payoff that a block producer can obtain by including, ordering, and excluding transactions from a block. We assume that there is one single party who has the full power to do so, and we assume that this party wants to maximize its payoff, so it doesn't want to have some altruistic motive. And as we have discussed, there are lots of negative consequences of MEV. We've particularly discussed about how it inhibits value. So many people see MEV as one of the main bottlenecks for getting more activity on chain. It means that it's a threat to fairness of decentralized markets. It leads to inefficiency of the markets and instability. Front running leads to user losses, and importantly, it leads to centralization of the consensus system. In this presentation, I'd like to show that these two are very separate problems and require separate solutions. But first, we'll go into an overview of these things. So if MEV is so bad, the logical next step is to try to mitigate it. And usually this is done either in or out of protocol. And with protocol, I purely mean the Ethereum protocol, so the consensus rules that govern how blocks are created and how we move on to the next one. And the objective is usually to decrease the costs that users face. And this is done by either removing the right for a single party to control the entire block, or it's done by changing the incentive structure here. So out of protocol, we've seen that some applications like Andrea, which has been mentioned before, work on protocols where it doesn't really matter in what order transactions are included in the block, meaning that the person that has full control to order the block doesn't get an economic payoff from this. And other protocols like the fair ordering that CM was talking about as well, they remove the ordering rights of the block producer. Yes.
So there's one thing I don't understand, that is, if we remove MEV, the staking yield will go down, the staked amounts will go down, and then the security of the protocol will decrease. So if you want to maintain the same level of security, then money has to come from somewhere. So then should everybody else pay more for their transactions? Or how do you see that trade-off?
Yeah. So how we see it is the issuance that a block producer gets for creating a block. So this is like the amount of ETH that's created and sent to the person that makes the block, the proposer, should be sufficient for you to have an incentive to create the blocks, and should be sufficient to guarantee the economic weight behind the chain. So if the amount of MEV decreases, then yes, you would say that maybe less people stake. But then if the ecosystem decides that there's too little stake, what we could do is we could adjust the issuance to increase it. So if MEV decreases, we could adjust the issuance. And this is kind of what you're getting at. Everyone would be paying a bit more because issuance could be seen as a transfer between those that don't stake and that do stake. If that explains yeah, so MEV shouldn't be essential to the security of the chain. It's also important because MEV is very spiky. So if we're in a regime where there's little MEV, we don't want to have less security for the chain. Okay, so I'll start by talking about out-of-protocol mitigations, which we've been talking about mainly, and I'll try to decompose it along these two axes. I don't know if these are the right axes to think about, but it's helpful for me, and we'll see if it holds up over time. So I'd say that either you could mitigate MEV via infrastructure, which means that multiple applications, so multiple AMMs, they share some sort of infrastructure to mitigate MEV, or you can do it via an application, and you can do rebating or preventing. And rebating is somewhat interesting here. It means that you allow someone to extract the MEV, but you do this for a price. So, for example, if someone were able to extract $100 of MEV, you ask them to pay a competitive price that's hopefully somewhere near the $100. Or you could do via preventing, which means that they're not allowed to extract the MEV. And we'll go through some examples of all of these, and some of them we have seen, so we'll try to move on them quickly. So the first example is about an application trying to prevent MEV. And for this, I really like the function maximizing AMM from Andrea here. And the objective is to eliminate the loss versus rebalancing. So this is the arbitrage losses that LPs face from the system. And it's inspired by the frequent batch auction literature from British Tangent and Jim. So how it works is the function maximizing AMM batches trade together over some period of time, settles the net trade against the AMM at the marginal price after the batch, and where the marginal price is the price of an infinitesimally small trade. So if you would have three regular traders where two of the green people are buying, one of the red person is selling, so the net trade between the regular traders is 2 ETH, And then there are some arbitrageurs who observe this and the external market price. And what they'll do is they'll insert a trade such that there's no arbitrage left. And this is they'll do this by inserting the right volume of trade, such that the marginal price after the batch is equal to the external market price, and thereby hopefully eliminating the loss versus rebalancing here. And then another way to eliminate loss versus rebalancing, so to have the same objective, is via rebating. And Siamak talked about this before as well. It's the MEV capturing AMM. So instead of having a sophisticated system of the frequent batch auction, what it does is it hosts an auction for some person to extract the rights to extract MEV. And then the proceeds of this auction are given to those who are extracted from. So if there's an example, some external market is willing to trade 1 ETH for 2,000 USDC, and there are some arbitrageurs in the middle who observe both the external markets and the decentralized markets, which is the MEV capturing AMM in this example. The MEV capturing AMM is willing to trade 1 ETH for 2,500 USDC. So the arbitrageurs will observe this and they'll buy ETH at the external market and sell it at the decentralized markets. And hopefully they'll be willing to pay a competitive price for this. And the auction proceeds are again given to the LPs of the MEV capturing AMM. So this rebating scheme is actually quite easily generalizable, at least conceptually. And this is what Flashbolts has been doing. So they have developed a system called MEV Share. And what it does is it lets a user decide how much information to share about their transaction. So a user sends their transaction in either encrypted form or to some trusted party, and lets the trusted party share some of this information to arbitrageurs. So what it does specifically is a user sends their transaction to an auctioneer and tells the auctioneer, you're allowed to say that I'm trading these assets on this pool, for example, and people can bid for the right to extract MEV from my transaction. And the bid is something that I want to receive back because this is value extracted from me. It's originated because of my transaction. So then there should be a competitive market again of arbitrageurs, and maybe someone thinks it's worth 100 USDC, maybe someone thinks it's worth 40. It's more difficult to ascertain because there's only limited information about the trade. The person who bids the most receives the right to sequence my transaction, and I receive the payment of it. And this depends on some trust assumptions, which Flashbolts has been working out. But it's a way to generalize this rebating mechanism. And you can see that generalizing rebating might be easier than generalizing preventing, because preventing requires a lot of study, like Andrea has done, about frequent batch auctions, whereas rebating is conceptually easier by just hosting more auctions.
So can I ask a clarification question?
Yeah.
So I'm going to take the mic to be a good citizen. So this is very interesting. Thanks a lot. I appreciate it. So I'm thinking when I see this, there will be two cases. Either the price you have to pay to be able to extract is going to be just equal to the profit you can make, in which case nobody will participate because there's no money to be made. Or it's going to be lower than the profit you can make, and that difference is going to be a loss to the initial customer. Am I wrong?
Yes, but I don't know if it's necessarily a loss. So as some people have said, MEV is usually seen as bad, but you can also see it as like a payment for a service. So potentially you don't want to think about where should I ultimately send my trade. I'll just send it to some exchange. And then this person is very good at thinking, how should I route your trade? And so they will kind of be like your counterparty and route your trade elsewhere and give you some payment for this back. And so, yes, you lose a bit, but it doesn't necessarily, I wouldn't necessarily think that this is bad. If that makes sense. So then how could we make infrastructure that's aimed at preventing MEV? And an interesting example of this is private order flow in a profit-seeking world, which is a paper by Tushar Babel from the Ari Jules lab. And what they do is they use a similar technique as MEV Share, where they use one trusted party who receives transactions in either encrypted form or just purely based on trust. And this trusted party is contained in the trusted execution environment, which has the following guarantees. It has integrity. So other people are not allowed to mess with how the operations in the TE work, and it has confidentiality, so people can't observe what's happening in the TE. And this trusted party in the TE pre-commits to some way to order your transactions. So it could be first come, first serve, it could be based on priority fee or randomly. And what this is supposed to do is this is supposed to prevent people from front running your transactions, because if you submit your trade to this person in the TE who is either trusted or in some encrypted form, and it pre-commits to some way to order your transaction, then surely you can't be front run by someone else. So this might have been a lot of different information, and the goal of this talk is not to convey specific ways of preventing MEV. It's more aimed at giving some sort of way at looking at it. So I like to see it along the ways of infrastructure or application, preventing or rebating. This talk is meant to say that a lot of people are working on mitigating this MEV out of protocol, so outside of Ethereum consensus rules, and that there are many different approaches. And I feel that the ecosystem has some confidence that this should quickly lead to a rapid shrink of the amount of MEV extracted from end users. Whether that's true is something that we'll see.
You stop me if I'm taking
Go ahead,
too much
please.
of your time. Thank you very much. Your question made me think of something. Your answer to my question made me think. So it's maybe the question is the following. Does MEV create value for society? If it does, then we want to know what is the value created and who should be paid for this value provision. And if it does not, then we should try to make sure it doesn't happen. And so I think this is suggesting that maybe an important question to ask is what kind of value is being created here?
Yeah. So I agree it's an important question to ask. I think an important caveat as well is how much can we do about it? And in the next couple of slides, I'll show what the limitations of Ethereum the protocol are. So we can't do everything to stop it. If we would basically be like a centralized service. So there are some limits to what we can do. And then secondly, what the value is of MEV. So I think, yes, it creates societal value. As we've seen before, MEV is also arbitrage, and you could argue that arbitrage is very valuable. But as presented earlier, there's too much paid for it. So you would say that there should be a way smaller payment of the amount of MEV going to the person doing the arbitrage, but still it creates value, of course. So yes, there is value, but it inhibits a lot of value as well. But let's talk about that more later.
Julian, can I ask a question? Maybe a little related to what Bruno's saying. Is there a modeling framework to think about sort of think about welfare in this context? It seems to me part of the issue here is like, yeah, from a more formal perspective, how do we think about these different forms of MEV and what are the welfare implications purely? Like when you say good and bad, what are we talking about? We're talking about increases in welfare or decreases in welfare. At least I think that's what economists are talking about. So is there any mental model?
So I think this gets a bit at like the application infrastructure change. It's difficult to say whether there is such a model because it depends a lot about what you know about what's happening on the applications. So infrastructure knows less, applications know a lot more, and Ethereum knows basically nothing what's happening. So whether you have such a model depends on what perspective you're taking, I guess.
But okay, I guess Barb is also like, even from a modeling perspective, what is the space in which MEV exists? So you've heard of things about like some people saying maybe I don't think liquidations are bad and I think checks text arb is bad or something like that, right? But so then there's probably some useful abstract space from which we can think about these different kinds of MEV itself, because it seems like some of this discussion is not very well defined in terms of thinking about is MEV quote good or bad?
Yeah. Okay, let's talk about it later. I'd like to show now how it doesn't really matter how we see MEV. There are some fundamental limits that we can't get over. So then it doesn't matter. And I see the question in the back, but let me get to it later. So we've seen infrastructure preventing MEV. Why can't Ethereum, the protocol, be this infrastructure preventing MEV? So Ethereum could take away this right to include, order, or exclude transactions from a single person and say you have to order according to some fixed rule. But what we've seen in the ecosystem is people have voiced that there are some negative externalities that come from the fixed ordering rule. Random ordering would lead to spam, and first come, first serve ordering would lead to a latency arms race, which is not good. And it's difficult to actually have a first come, first serve ordering in a decentralized setting. So even if I send my transaction and people in the first row all agree that my transaction was sent before someone who says it in the back, people in the back would see this transaction earlier than my transaction. So even if someone's individual observation of transactions could be transitive, so one sees X before Y before Z, the other person sees it in a different way, it doesn't mean that the global ordering is transitive. And this is something that's difficult to get across, certainly if we have validators all over the world. They'll observe things in different orders, and we have to break these orders in usually in quite a random way, for example, by alphabet or something. And this obviously it doesn't achieve the goals that we want. And likely this will happen most for transactions that are most related to this first come, first serve. So you could expect front runners to be very quick in sending their transactions after they observe a transaction, whereas if there's a transaction that's not so time relevant, people won't care too much to front run it. So this, the previous slide is to say that Ethereum can't really be the infrastructure preventing MEV. Can Ethereum be the infrastructure rebating MEV? Well, I'd like to say this is not possible because Ethereum has to remain very neutral. So first of all, Ethereum is not aware of what's happening at the execution layer. So the consensus protocol doesn't know what's happening. So it doesn't know what MEV is. So even if it were given the MEV, it doesn't know how to redistribute it because it doesn't know what LPs are, it doesn't know what AMMs are. So how can it possibly decide who receives it? And let's say that we somehow solve this challenge. Ethereum should never be in a situation where it has to choose between two people. So let's say that there is an arbitrage between one decentralized exchange and another. How should we rebate the arbitrage proceeds between these two different exchanges? This is a difficult question. Probably both exchanges would like to lay claim to this money, but Ethereum can't really decide who should be giving it. And this extends further. So even if you were to have some way to do this, we can't really implement this because then you'd be favoring some applications over others. And this is a very fundamental thing because Ethereum isn't only there to satisfy DeFi applications. It should also be there for basically any application that pops up in the future. So we don't want to favor the DeFi application that we see now over some applications that we see in the future. Whether this is something that might change is up to the ecosystem, but this is how I would see the general discussion now. So Ethereum can't prevent or rebate MEV. What can it do? You might ask, like, are we actually doing something? Well, it turns out there's an entire roadmap for this, which is Vitalik's vision, and preventing MEV in protocol. So we move to Ethereum's consensus rules now. Is more about preventing centralization on the consensus participants. So it's more about the role of the extractor and not the users who lose money, because MEV gives a lot of incentives for the extractor to behave differently, which is what we'll see here. So this is a picture of Vitalik's roadmap, and it contains a lot of different parts. So this is PBS, which has been talked about a bit. There's inclusion lists, distributed block building. There's a lot. I can't go into all of it now, but we'll go into one example, which is proposer-builder separation. So hopefully this gives some clarity. So proposer-builder separation recognizes that building blocks is very hard. First of all, it's computationally difficult because there are a lot of options that you could make, and you need to find just the right combination of transactions in the right order to extract the most MEV. And it requires private order flow. And private order flow is people sending transactions to one specific person and not to other participants. And the person who receives more transactions logically can extract more MEV because it has more options. And so this is an empirical observation. And Ethereum wants geographically distributed, unsophisticated validators. And I think it should be clear that these two just simply don't go together. And this is where the statement comes from that MEV increases the centralization of consensus participants. And this is where proposer-builder separation comes in. So proposer-builder separation is not supposed to change the state of the blockchain or what would actually happen. So MEV would be extracted. This is not what proposer-builder separation is about. Proposer-builder separation is about the role of the extractor and what the incentives of the extractor do. So what it does is there's a proposer who's the person that's recognized by the Ethereum protocol as having consensus duty. So it has to attest to which blocks it has seen on time, which blocks are valid, etc. And this person can't also be the sophisticated builder. So we firewall these two things and we say every proposer should be able to outsource its block construction to some sophisticated builder because clearly it can't do it itself. And there are a lot of economic incentives to do so. So concretely, we have a network of validators that's recognized by Ethereum protocol, and every validator is allowed to choose some builder that creates its block. The validator then gives its right to build the block to a builder, and the builder gives some payment to the proposer for this in return. And users mainly interact with the builder, as in the builder determines the order of transactions. So proposer builder separation, I guess fundamentally is about the counterfactual. So it might seem very weird that we're purposefully maybe accelerating what happens with MEV. So you could say that PBS leads to more sandwiching, as we've seen before. But that takes a different counterfactual, I'd say. So usually people assume that the counterfactual is there's just proposers who happily order transactions in some fair way based on what they do, and they don't have any economic incentives, but clearly they do. So instead of waiting for these sophisticated builders to take over a larger part of the Ethereum validator network, we allow the current validators to outsource to these builders, because builders don't necessarily want to be a validator. They just want to order transactions. And if builders were all validators, then we'd be closer to like 51% attack and consensus instabilities. Whereas if builders construct a lot of the blocks, then we don't have these 51% attack difficulties.
So this is because there is no complementarity between being a validator and being a builder? So why will they naturally separate themselves from one another?
Yeah, that's like very much into the roadmap, but I would say being a validator has, let's say, 3 different main duties. It's attesting to consensus information. So there's not really MEV to extract here unless you're very, very sophisticated, but you're just attesting to whether you've seen a block and this kind of stuff. There's the role of proposing. So this means given a block, you're propagating it to the network and attaching like the right information to it. There's some MEV to extract here, because if you're able to propose later, then you can get a better block. But most of the MEV is just in constructing the block. And this is just a subset of the duties that a validator has. So we isolate these 3 roles and we allow different participants to fulfill different roles. That makes sense. So then the question is like, why can't the ecosystem do both simultaneously? Yeah.
So, sorry, are the proposers recorded on chain as well? So do we know who each? Thank you. Sorry. Do we know who each proposer is because their existence is recorded on chain?
Yeah. So proposing is one of the roles of being a validator. So in this case, we allow the validator to still be the proposer, and validators are recorded on chain because they have stake and they are like the consensus participants. So yes, proposers are validators, so proposers are recorded on chain.
And is the same true with the builders?
No. So builders are just outside parties, and the protocol doesn't know that they exist. Yeah. If that's all, or.
Oh.
Am I on time?
A very quick question, Ors. So when proposers were builders, you would think that MEV would be spread among many proposers, right? Because there are many proposers, but today there's maybe 3 builders. And, you know, one thing that we know is that if the market is very concentrated, then you can have some collusive type of outcomes. But is this separation maybe, instead of having MEV distributed to many proposers, now is just concentrated in the hands of 3 builders, right? Because maybe they don't pay the right price for each block.
So this is again about the counterfactual. I think you're using here the counterfactual that it would be distributed. I think the philosophy behind PBS is that this isn't the counterfactual. In fact, builders would then become validators, and so it would be centralized anyway.
Okay, I understand. Yes.
Okay, so I've tried to motivate now that Ethereum. Wait, let me move on a bit. So I've tried to motivate that Ethereum cannot do what applications do. As in, it has to remain neutral. It can't rebate and it can't prevent MEV that well. The logical question is then, can applications do what Ethereum does? So remove the centralizing incentives that come from MEV. And this is something that you observe in the ecosystem where protocol developers, which would be the one Spider-Man, point at application developers and say, please don't dump so much MEV on us because it makes our job very difficult. And application developers might have a similar sentiment where they feel the protocol isn't set up in the right way to prevent MEV. So everyone is pointing at each other and there's no clear solution. And I'd like to argue that we shouldn't be pointing at each other because these are very different problems that have different solutions, and there's not one single solution to 2 different problems. So the question would be, do MEV mitigation techniques remove MEV centralizing pressure? And I would say probably not. I'd like to motivate this with an example. And this is based on the previous presentation as well. So it's about loss versus rebalancing, which is the arbitrage losses per unit of liquidity. And this is, again, due to price differences on external markets and on the blockchain. And the blockchain behaves in discrete ways. So these price differences can be big. And what we've seen in the previous presentation is loss versus rebalancing is proportional to the slot time to the power of 3/2. So this means that shorter slots leads to less loss versus rebalancing. And while this is true, I would say that this applies to the MEV that's relevant for users, which is, of course, a very big part. But this is if you decrease the lever, then yes, you get lower cost to arbitrageurs, which could be good for users. But I'd like to say that maybe this is not so clear for the protocol. So suppose slot times magically became shorter. Then keeping all else equal, LPs suddenly are now much more profitable. And this is somewhat of a weird situation because they hold pretty much the same asset, which is some LP position. But now the only technical difference is that the slot times are shorter. So if you hold the same assets and suddenly it's much more profitable, you'd expect more liquidity to flow in to take some of these profits. So that's what would probably happen since revenues are split pro rata, so liquidity flows in. And then if you were to say that LPs hold some assets, then their returns should be determined by their risk-reward ratio. And so I'd like to argue that this shouldn't be based on how what the costs are of predictable arbitrage, because liquidity will adjust according to how much cost there are. And it's unknown how liquidity providers currently perceive the risk of these LP positions. This is something that's very understudied.
Yes. I mean, I understand the argument. In principle, what you're saying is there's a particular problem given by a particular application. You can't, design your particular, protocol based on that. But I think that this is all asking the wrong question, because the overarching question is an information question, right? The reason why there's MEV is because there's too much known about a transaction. Is there not a way to hack that up in such a way that the information about the details of the transactions that are relevant are just relayed at the wrong time? So is there not a way how you can, for instance, have, let's say, some form of encryption mechanism where you only reveal what the fees are and what the gas use is, and then you have a have a decryption part after the ordering has happened?
So yes, I see what you're saying, but I think the information part gets a lot about what's relevant about MEV for users, and not so much about what's relevant about MEV for the protocol. So even if you're saying that there would be very little MEV because maybe there's a lot of information symmetry, we can't encrypt everything. So for example, we probably don't want to encrypt the state of a Uniswap pool because then users have no clue what they're trading against. And so MEV originates here because an arbitrageur can see the state of the pool and it sees the external markets. It doesn't have to know anything about incoming transactions. Incoming transactions we can encrypt, and this is also some part of the roadmap. But it wouldn't eliminate all of the MEV. So okay, we can talk about it more later. But so let's say we have these shorter block times. There's less arbitrage losses per unit of liquidity. So there's less MEV per unit of liquidity. Then more units of liquidity flow in. We don't know exactly how much more units would flow in because we don't know how liquidity providers see like the risk of LP positions changing based on slot times. So the net effect of the MEV mitigation technique on the amount of total MEV that's exposed at the protocol layer is unclear, which is the argument that we make in a recent paper. So that's to say applications cannot entirely do what Ethereum does, which is essentially isolate the centralizing pressures of MEV on proposers. But it's very clear that it's great for users, of course, to have less MEV. So this is to say these are two very separate problems. Solving the centralizing pressures of MEV on the protocol, or solving the pressures that MEV places on users. And there's not one single solution to two separate problems. And this is amplified because the Ethereum protocol is so constrained in what it can do because of its neutrality, its limited awareness. So that was most of what I had for this presentation. So I'd like to end with 3 takeaways, which is many people are working on mitigating MEV out of protocol and not necessarily in protocol. There are lots of different approaches out of the protocol, which is the infrastructure, applications, preventing, or rebating. And there's not one single solution to two very separate problems, which is the centralization that MEV imposes on the consensus participants of a blockchain protocol, and the problem of value attracting, which leads to user losses. So that was it. And you can scan this QR for the slides if you like.